So good morning, good afternoon, and greetings of the day to all the students. Welcome back to our channel. So in this video, this is the part 3 video, and in this video we'll be dealing with the assembly and assembly constraints of the components that were built in the part 2 video for the IC engine, for a theoretical IC. So till now we have got an overview, we have got what are the components involved, and how do we make those components, how do we put the dimensional constraints, how do we put the geometrical constraints on it. And after completing the model, after exercising the 3D operations, after exercising other operations such as Boolean, etc., we have completed all the models, and now we are working on the assembly part. Okay, so as far as the assembly part is concerned, I will tell you the all the procedures regarding it. So let us start. चलो देखो, सबसे पहले the first thing which you have to do in order to add any component or any model which is made in the Siemens NX5 is that you have to click on add component. After clicking on add component, you will click on anything which is required. Like for example, I have to add fixed pin. I will click on fixed pin. After that, I will click on select object and I will hover the mouse, and as my mouse will move, the object will also move. After that, I have placed that I can rotate the object which has been put in the display window. Okay, so you can see that it can be rotated, it can be moved, etc. So these are the loaded parts. You can also browse the parts from the place where you have saved them, and you can put those loaded parts or the browsed parts in a display part, as a display part. So when the object enters the graphic display window, it becomes a display part. Okay, so the object has already been added. So this is the main method of how to add any object. So I have shown you the method. All the components have been added in this manner. If I want to increase the number of copies, I can simply click on count 1, 2, 3. For example, M6 threaded bolt was added 4 times, so it is 4 times. The D40 connecting pin was added 2 times, therefore it is 2 times. The piston seal ring was added 3 times, it can be 3 times. So this is the way of adding any of the part. After adding the part, we will have to orient the object, we will have to move the object, and then we will have to put a constraint on the object. For example, this object, this has been oriented as per the XYZ axis, that it is in the XY axis and the extrude is in Z axis. And after that, I have placed the object as per my demand. So how did I place that? I put a concentric, this concentric assembly constraint. The first object was the circle and the second was the origin. So they both got coincided and it got placed over here. Okay, so after we have made the circle, the concentric, after that what we'll do, we'll put an assembly constraint that is fixed, and we'll select the object and it will get fixed. After that, we will add the connecting pin of diameter 40. Initially, I added diameter 40 only one times, and I added diameter 40 connecting pin again after adding the crank. So we can ignore that. So I added the connecting pin, and after adding the connecting pin, what did I do was that I constrained the connecting pin along with the fixed pin. For example, if I show you that this is the fixed pin, okay, I applied it. After that, I added one connecting pin, and I will rotate it like this. Okay, so here I will just simply put the fixed constraint on this object, and this will make it fully defined. After that, what I will do is that I will take this circle. I will use the concentric option, this circle, and then I will take this circle, the circle which is obtained after the edge blend. I will take that, and you will see that the connecting pin gets connected over here. And this connecting pin, if I will try to move it, it will not move. It can only rotate. It can only rotate. For example, like this. You see the assembly constraint is also getting rotated. It will only rotate in this manner. It will not rotate in this manner. It will not rotate in this manner. It will not move in any of the manner. Okay. So this is the way I did for the fixed pin and the connecting pin. After that, what did I do was I added the crank, and the crank was added, and the same manner I just added the crank, and I applied the assembly constraint, and I did the concentric. I selected this circle, and after that I selected this circle, and it got added. You see, the crank got added. The same procedure what we have done till now. I will take this, I will take this, I will take this, and delete. Okay. So I will show you the crank, I will show you the connecting pin. So this has been added, and the same procedure will be used for adding the connecting rod. How do we align the connecting rod with the connecting pin? Keep in mind that the larger diameter will be on this end with the connecting pin of diameter 40, and the smaller diameter will be towards the other end, that is for the piston and connecting pin of diameter 20. After that, what we'll do, since we have also taken M6 threaded bolt, we had time to do that. So we added M6 threaded bolt and placed it in a position so that all of them are visible. So how are they aligned? For example, if you will see this, if I will try to move it, it will only be moved up and down. Secondly, it will only be rotated in this direction. It will not rotate in this direction. It will move in this direction. It will not rotate in this direction. It will move in this direction. That is, movement is in one axis, and on the same axis, about the same axis, it can rotate, as you can see. So this has been obtained with the help of the constraint, that is the cylindrical constraints. Two objects along a rotatable linear axis. ठीक है, इसमें हम लोग लेते हैं और इसमें क्या करते हैं, एक मैं सिंपल तरीका करके दिखा देता हूँ. फॉर एग्जाम्पल, इफ आई डिलीट दिस, ओके, और इसमें मैं कंपोनेंट ऐड कर देता हूँ M6 थ्रेडेड बोल्ट, सेलेक्ट ऑब्जेक्ट, ये था. अब मैं इसको थोड़ा तरह कर देता हूँ ताकि अपना दिखने में सही हो जाए. और अब क्या करेंगे अपन, assembly constraint will be used, the vector one. First of all, the vector will be required. Okay, so the vector इस डायरेक्शन में है, इसको हम लोग रिवर्स कर देंगे. स्पेसिफाई पॉइंट, तो इसमें हम लोग को पॉइंट स्पेसिफाई करना है, तो उसके लिए हमें इसको हटाना पड़ेगा. पिन और क्रैंक को और कनेक्टिंग रॉड ये हटा दिया. उसके बाद हमें पॉइंट स्पेसिफाई करना था, तो इसका सर्कल ले लिया. ठीक है, फिर हमें स्पेसिफाई वेक्टर करना पड़ा, तो हम लोग ने इसको लिया और डायरेक्शन ये रहा. और स्पेसिफाई पॉइंट था, तो हम लोग क्या करेंगे कि इसका जो ऊपर का पॉइंट है सर्कल का, सर्कल आपको हाईलाइट होते हुए दिख रहा है, बस ये वाला पॉइंट जो है आर्क सेंटर, ये हमने ले लिया और क्रिएट जॉइंट कर दिया. तो जॉइंट हैज बीन क्रिएटेड. अगर आप वेक्टर उल्टा ले लेते तो जॉइंट विल बी क्रिएटेड ऑपोजिट, तो मतलब कि बोल्ट जो है वो रिवर्स डायरेक्शन में होगा. तो कुछ नहीं, आपको फिर से अंडू करके जो वेक्टर है उसे चेंज करना होगा. तो आफ्टर दैट यू हैव डन दैट, यू विल सी that this bolt has been constrained to movement in only one linear axis, and that it can only rotate in this axis, and it will not move, it will only move in this axis, it will only move in this axis, it will not rotate. Okay, so I think that it is understood now. चलो, अब ये चीज हमारी हो गई। अब अपन क्या करेंगे, after this we will move on to the piston. As you see that piston plays a very important role in the IC engine. So we will do what? We will add the piston in it, or first we can add the connecting pin. So whatever you want, you can add it first. So if you will add the connecting pin, you can add the connecting pin. The connecting pin will be constrained in the manner of that the center line of this connecting pin and the center line of this circle will be aligned. How will you do that? Using this touch align feature. After that you will click on align. After clicking on align, you will select the center line of connecting pin, and after that you will select the center line of connecting rod, and then it will get aligned. After that what you will do, that connecting pin will be aligned, but it will be either more on the right side or more on the left side, that does not matter, it will be taken care of later on. You will add the piston, and after adding the piston you will again align the center line of the piston and along with the center line of the connecting pin or the center line of the connecting rod. After that what you will do, you will apply the assembly constraint, and you will apply the constraint of distance, and distance constraint will be applied between the face of this connecting pin and face of this piston, and it will be 0.5 because the connecting pin was 81 mm and the piston is in the same direction 80 mm. So on either side there is 0.5 mm if you look into the radius. So distance will be 0.5 mm. Then automatically this connecting pin will get aligned in such a manner, it will not move. If I try to move this connecting pin, you may see that it will not move. It will only move in the direction of piston stroke. Understood? That is why. It will rotate, but it will not move in this direction. Okay. Now, we come back to the piston, and piston has been added, the connecting pin has been added. After that, we'll add the piston seal rings. You see there are piston seal rings. And how do we add that? Let me show you by doing one. The piston seal ring has been deleted from here, no problem. I will add the piston seal ring again. Add component, I will add the piston seal ring and I will place it over here. After that, I will keep it like this and I will apply. After doing that, I will take the assembly constraint, and in the assembly constraint, the concentric assembly constraint will be used. Okay. So if you remember in the piston that the inner diameter, the groove of the piston was made by using a circle of 78 mm, 78 mm and 80 mm, and the seal ring was made by using 78 mm and 81 mm. So if you will see that the seal ring has been placed accordingly. So we took the center and the same side of the circle of 78 mm of the seal ring, and they got concentric. After that, what we'll do, the most difficult part of any assembly constraint that has been used in this IC engine assembly is the cylinder. So first of all, what you have to do is that you will have to add the cylinder. It will get added in any of the fashion. After adding the cylinder, you will have to align the cylinder center line with the center line of the cylinder. After that, what you will have to do is that you will have to make this uh, what do you say, we will have to move this cylinder in either right side or left side. Okay, this aligning the cylinder with the piston is very difficult because it sometimes get aligned in the reverse direction. The cylinder which is the reverse direction will not be usable for animation or graphic purposes. So you have to make it aligned in the proper direction. So the same concept is that the vector which you are taking and the point which you are taking should be correct. That assembly constraint, when you will apply the aligned, so it should be correct, and that is the only thing. Okay, after that, if that does not work with your system, you can use the object of constraint two objects in a linear axis. So the linear axis will be this. Okay, or you can also use okay, no, that will not be good. You can use either of the two, either the align option or the slider option, or you can also use the concentric option just for alignment purposes. That you have used the concentric, you have used this circle, and the outer diameter, the inner diameter of the cylinder and the outer diameter of the seal ring, and it will get placed automatically. After that, what you will have to do is you will have to take the piston in the position of top dead center, and you will have to move the cylinder in a hit and trial manner, like using the component and then distance, and by like moving it 20, 30, 40, 50, and then will you get, after that you will do apply. After applying, you will again move the connecting rod. If you will see that the connecting rod is not getting in contact with the connect with the uh, what do you say, the cylinder, then it is okay. If it is getting in contact, then it is not okay. So it is not getting in contact, is barely मतलब दूर है उससे, so it is good. So if you find it good, then what you will do is that you will take the uh, assembly constraints and you will put the fixed constraint on the cylinder, and then the cylinder will get fixed. And if you will do any mistake in the assembly constraint with the cylinder, there are only two things which might happen. First is the cylinder will get reversed. Second thing is that the cylinder will start moving with the piston. So these are the two things which will show that you are going in the direction, but you are little bit getting swayed in some different direction. That means you are close to the correct result. So with this, we will complete the assembly constraint of our IC engine, theoretical IC engine, and you will see that the IC engine has been successfully made. And what is the symptom, or what is the indication that IC engine model has been successfully assembled? That is, if I try to move any one link, it will give me the desired result as that of a theoretical IC engine. So I hope that this was informative for you, and if you want that we should make any other mechanism also, or any other assembly also in NX CAD or in any other software, do let us know. And for the time being, I will also upload a new video, for a bonus video for how to install Siemens NX CAD, and I hope that you find it useful. So keep your support, keep liking it, keep subscribing, and keep sharing our videos. And till the next time we meet, goodbye.